Smart Dustbin. A Smart Dustbin is an automatic lid opener system for the garbage, as you can see here. Now, what are the components of the Smart Dustbin? The two main components of the Smart Dustbin are the Ultrasonic Sensor and the Servo Motor. The ultrasonic sensor is used to detect any movement in the front of the dustbin, and the servo motor is used to lift the lid of the box as soon as any person is detected and close the lid once the person is gone. You can make a smart dustbin with an old dustbin present in your home or with any cardboard box. So let's see the working of the components. First is the ultrasonic sensor. The ultrasonic sensor, also known as HCSR04, is a sensor that can measure distance. It emits an ultrasound at 40,000 Hz, which travels through the air, and if there is an object or obstacle on its path, it will bounce back to the module. Considering the time travel and the speed of the sound, you can calculate the distance. The configuration pin of the sensor is the pin number 1, which is VCC. Second is the trigger pin. Third is the echo pin. And fourth is the ground pin. The supply voltage of the VCC is +5 volts, and you can attach trigger and echo pin to any digital input-output in your Arduino board. Now, how the ultrasonic sensor works. In order to generate ultrasound, we need to set the trigger pin on the high state for 10 microseconds. That will send out an 8-cycle sonic burst, which will travel at the speed of sound, and it will be received by the echo pin. Then the echo pin will output the time in microseconds the sound wave travel. For example, let's see how we can calculate the distance. If the object is 20 centimeters away and the speed of sound is 340 meters per second, then the sound wave will need to travel about 588 microseconds, as we know distance equals to speed into time. But what you will get from the echo pin will be double that number, because the sound wave needs to travel forward and also bounce backward to the module. So, in order to get the distance in centimeter, we need to multiply the received travel time value from the echo pin by 0.034 and divide it by 2. The servo motor. Inside the servo motor, there is a pretty simple setup. It has a small DC motor, a potentiometer, and a control circuit. Servo motors are generally used to control position and speed very precisely, but in a simple case, only position may be controlled. The motor is attached by gears to the control wheel. As the motor rotates, the potentiometer's resistance changes, so the control circuit can precisely regulate how much movement there is and in which direction. When the shaft of the motor is at the desired position, power supply to the motor is stopped. If not, the motor is turned in the appropriate direction. The desired position is sent via electric pulses through the signal wire of the servo motor. So, there are 3 wires in the servo motor: the positive, the ground, and the signal wire. The servo motor is controlled by the pulse width modulated signal through the signal wire. A pulse is sent every 20 milliseconds. The width of the pulse determines the position of the shaft. For example, a pulse of 1 millisecond will move the shaft anti-clockwise at -90 degrees. A pulse of 1.5 milliseconds will move the shaft at the neutral position, that is 0 degrees. And a pulse of 2 milliseconds or more will move the shaft clockwise to +90 degrees. You can see that in the signals given here. Now let's have a look at the circuit diagram here. First of all, for the ultrasonic sensor. we will connect the VCC of the ultrasonic sensor to the Arduino with 5-volt pin, then the trigger pin to the 7th pin of the Arduino, the echo pin to the 6th pin of the Arduino, and the ground pin to the ground of Arduino. For the servo motor, we will connect the VCC and the ground pin to the 5-volt and ground of the Arduino, and the signal pin to the 5th pin of the Arduino, which is the Let's have a look at the code here. First of all, we will include the servo.h, which is the library for the servo motor. Then that's servo my servo, which means to create an object my servo of the type servo. Then we will declare a variable position to give the original position of the servo motor. Then we will declare two variables, constant int trigger pin equals to 7 and constant int echo pin equals to 6, which means we are connecting the trigger pin of the ultrasonic sensor to the 7th pin of the Arduino and the echo pin of the ultrasonic sensor to the 6th pin of the Arduino. Then two variables, long duration and float distance, to store the respective values. Then we have two functions here, void setup and void loop. In the void setup function, we have my servo.attach pipe, which means we are connecting the signal pin of the servo motor to the 5th pin of the Arduino. Then we will declare the pin modes of the trigger pin and the echo pin. The trigger pin is the output pin and the echo pin is the input pin. Then my servo.write position, which means that we are setting up the position of the motor originally, which is at 0. Then in the void loop function, we will write this piece of code to set the working of the ultrasonic sensor as we have already read. First of all, we will write digital write trigger pin equals to low, the delay of 2 microseconds, digital write trigger pin high, the delay of 10 microseconds, to keep the trigger pin high for 10 microseconds, then digital write trigger pin low. Then we will write duration equals to pulse echo pin comma high. This means that we are taking input of the time from the echo pin and storing it in the variable duration. And for distance equals to 0.034 into duration divided by 2. This is to find the distance between the person and the dustbin. So if the distance is less than 20 centimeters, then we will open the lid, which means my servo.write position plus 90 and give a delay of 1000 microseconds, which is 1 second. Else, if there is no person or the person has gone, then we will take it back to its original position. My servo.write position, which is the original position, to close the lid. Then give a delay of 300 microseconds. And here is the end of the code. Now let's make the Smart Dustbin prototype here. First of all, connect the ultrasonic sensor to the front of the dustbin, and inside the dustbin, connect the servo motor like this. Then close the lid and make the connections with the Arduino and place the Arduino on the side. Burn the code in the Arduino and let's see it's working now. So in this video, we learned about the working of the ultrasonic sensor and the servo motor, how to interface it with Arduino and make our own smart dustbin using it. If you like this video, give it a thumbs up. Please like and comment and subscribe. Thank you.